Project Dad. For our capstone project, we worked with our sponsor company, Novatel, to create a small portable device that will allow real-world remote data monitoring of Novatel products in agricultural cases around the world. Our team and roles are as follows. The final deliverables that we set out to accomplish were our physical data acquisition device, a proof of data transmission that shows that we can successfully transmit data remotely, and design documentation, including an assembly manual, as well as technical documentation outlining all of the specifications of the device.
Here is our DAD device and a quick overview of all its features. We made a 3D printable ASA enclosure that is resistant to high-intensity UV. It is also structurally and environmentally strong. As part of our design package, we created a detailed CAD drawing so that our models can be easily recreated and modified as necessary. These are some of the embedded features in our enclosure. We have an O-ring for providing a watertight seal, an air vent for pressure relief during the shipping of the device, and a fuse holder so you can easily change the fuse.
We used 3 capes to achieve the desired functionality. An RS-232 cape handles wired sensor communications, a SkyWire cape gives us LTE capabilities, and a custom-built protoboard cape controls LEDs, monitors voltage sense lines, and powers an external temperature sensor. We also have a battery management system that handles backup power when the tractor is turned off or other farm vehicle. It handles charging and discharging and also balances battery cell voltage. Our overall power system uses a T between the tractor or other farm vehicle alternator, supplying a voltage stabilizer which drops the voltage down to 12 volts. This charges the battery pack and also powers the BeagleBone Proto Cape, which drops down the voltage for the BeagleBone and also delivers 12 volts to the LEDs.
A large part of the DAD device is the software and remote accessibility components. The DAD uses point-to-point protocol, or PPP, for cellular internet connectivity. This is controlled and configured by a Linux daemon, PPPD. The PPP daemon is responsible for extracting information from the SIM card and communicating with an internet provider or carrier. Remote accessibility is handled by ZeroTier. ZeroTier is a Linux client installed on the DAD and configured through a web application. All devices connected on the same ZeroTier network are accessible from any other device on the network. This allows for our remote accessibility via SSH and SFTP. We implemented finite state machines for our LED indicators in Python, which rely on threaded processes of input fetching and state handling in order to ensure state changes are on the fly. These indications include our power and internet connection strength.
We also performed some testing in a few different scenarios to ensure that our device met the requirements. As you saw in the intro video, we brought our device out to a farm and installed the device on an agricultural vehicle. We were able to determine that the indicators were effective in a real use case and visible from the left photo here, as well as capable of withstanding minimal vibrations. We connected to one of the Novatel devices that were installed and were able to capture the data that is plotted on the right. This shows the trajectory that the vehicle took through the farm field. This is a sample of some of the data that the device will be constantly logging while it is on the fly. The sense lines show the vehicle, V-bus, and battery voltages that are constantly being detected, as well as the temperature from the temperature sensor. We were also able to successfully transfer data from the device to one of our laptops using the SFTP protocol. To ensure that our device met the requirement of being able to protect against water ingress, we put it in a shower to do a water test. There was minimal leakage into the enclosure, which we have determined would be as a result of the slight bowing effect you see in the right image, and would be easily fixed by installing a different O-ring. Thank you for coming to our presentation for Project DAD.